In my compound interest video, we looked at how compound interest works. We found that compound interest is calculated based on the principal plus any interest that's accrued and therefore can be thought of as interest on interest. The examples we looked at were all compounded yearly. However, in most real-world applications, interest compounds much more frequently than yearly. In this video, we'll look at the effect of different compounding periods on the interest earned or paid. By now, you're probably familiar with what interest and compound interest are. If you're not, please watch my video on compound interest before you watch this one. Compound interest is calculated based on the principal plus any interest that's accrued. Interest is added to the principal each period, and interest is then calculated on the new amount. In this video, we'll look at the effect of changing the compounding periods. Interest is usually compounded more than once per year. Common compounding periods are half yearly, or 2 times per year, quarterly, just 4 times per year, monthly, 12 times per year, or daily, which is 365 or 366 times per year, depending if it's a leap year. You can't simply input the number of years and per annum interest rate into the compound interest formula when the interest compounds more than yearly. To find the total number of compounding periods, we multiply the number of years, n, by the number of compounding periods, k. In addition, we need to convert the per annum interest rate to an interest rate per period, or we will overstate the amount of interest earned or paid. To do this, we divide the per annum or yearly interest rate by the number of compounding periods per year, k. Let's look at a couple of examples. Calculate the number of periods and the rates of interest offered per period. In the first example, we have 6% per annum over 4 years paid monthly. The periods is going to be n times k, so time times the number of periods per year. 4 years times 12, which is months per year, we get 48 periods. The rate is going to be 6% divided by 12, which gives us the rate per month. In another example, we're looking at 18% per annum over 3 years paid quarterly. Again, we do the periods is the years times the number of periods per year, which is going to be 3 times 4, which is 12 periods. The rate is the interest rate divided by the number of periods per year. It's going to be 18 divided by 4 is 4.5% per quarter. We don't need to calculate the number of periods and the rate of interest per period separately. We can do it within the formulae. Here I've shown the adjustments we made to 2 of the most common compound interest formulae. Put simply, we divide the interest rate by the number of compounding periods and multiply the number of years by the number of compounding periods per year. If we look at an example, Harry invests $4,000 at 8.4% per annum over 5 years. Determine the amount he'll have after 5 years if the interest is compounded monthly. What interest did he earn? We'll use the formula where we don't need to convert the interest rate to a decimal first in this example. To find out how much interest he earned, first we need to calculate the final or future value. Principal is $4,000, the interest rate is 8.4%. The number of years is 5, and k, the number of compounding periods, is 12 per year because it's monthly. Again, we're going to use the formula where we convert the interest rate to a decimal within the formula. We substitute all of our known values into the formula, and we can simplify and simplify further. And we get the amount that Harry would have after 5 years is $6,078.95, rounded to the nearest cent. To find out how much interest he earned, we need to take away the principal from the final value, and we get the interest earned was $2,078.95. Let's look at another example. We will use the formula where we need to convert the interest rate to a decimal first in this example. We have $8,800 placed in an investment account which pays 4.8% per annum, compounded quarterly. This time we're trying to find the account balance after 3 years, or the future value. Principal is $8,800. We've got to convert the interest rate in this example to a decimal, so 4.8% divided by 100 is 0.048. The number of years is 3, and the compounding periods is 4, because this is compounded quarterly. We have our formula, and we can substitute the values into our formula, and we can simplify it, and we get the future value of the investment after 3 years compounded quarterly is $10,154.27. Let's look at one more example. This time we'll compare if an investment is compounded annually versus compounded monthly. Will has $14,000 to invest. He invests some money at 9% per annum for 5 years. How much will the investment grow? How much interest will he earn? First, we'll compound annually. We're trying to find A, or the final value. Principal is $14,000. The interest rate's 9%. And the time is 5 years. This time it's annually, so we don't worry about K. We substitute them into our formula. And we can simplify. We find the investment will grow to $21,540.74. To work out how much interest is earned, we need to take away the principal from the final value. And we get interest earned of $7,540.74. Now let's look at when we compound it monthly. This time we have additional information, and that's K, which is 12 because it's 12 months. We divide the interest rate, 9%, by 12 to get the monthly interest rate, which is 0.75% per month. We also need to multiply N by K to work out the number of periods, which will be 60. We can substitute them into our formula, and we can simplify, and we get the final value of the investment, or the future value, is $21,919.53. To work out how much interest is earned, we take away the principal from the final value, and we get interest earned of $7,919.53. You'll notice that when we compound it monthly, we've earned approximately $400 extra over the term of the investment. And that's it for this video. Thank you.